Hello, my dear student. I'm Mr. Ktwala from Educators. Now, I will be with you in physics for Form 5. And today we are going to proceed with our discussion for our topic of rotation of a rigid body, for our subtopic of the moment of inertia. Now, before we proceed with our discussion here, we are supposed to remember where we ended on the last session. So on the last session, we tried to see how can we derive the moment of inertia for the hollow sphere that is rotating on an axis through the center. That is what we tried to see on the last session. And we demonstrated after that, we concluded by saying that the moment of inertia for the hollow sphere must be obtained by taking 2 divided by 3 times mr square, where the m represents the mass of the hollow sphere, while the r represents the radius of the hollow sphere from the axis of rotation of that hollow sphere. And after there, we tried to see that how this moment of inertia and for the solid sphere and also for the hollow sphere are related. And we observed that if we have the same mass, all of those spheres having the same mass, having the same radius, now their moment of inertia for the solid must be equals to 3 over 5 times the moment of inertia of a hollow. And we said that always the moment of inertia of a solid sphere is less than the moment of inertia for the hollow sphere. That is what we tried to see on the last session. So for our today's session here, we are going to proceed where we ended on the last session. As we see that the reason for a distribution of this mass, the reason for this is mass distribution, so the sphere is closer to the axis of rotation than and the hollow sphere. Kwamba kwa nini ile moment of inertia ya solid sphere ni ndogo kuliko moment of inertia ya hollow sphere. This is the conceptual question that are found in a chandi. That you should be asked, my dear students. Kwa hizo ni sasa ambao kwamba kwa nini moment of inertia ya solid sphere ni ndogo kuliko moment of inertia ya ile hollow sphere. Tutamwambia kwa sababu ya mass distribution of the solid sphere. Kwamba mass distribution ya solid sphere is very closer to the axis of rotation than in the hollow. Kwa hilo ndo reason ambao tutaweza kujibu kwenye hili swali ambao tutaulizwa. So after this one, let us go and see the moment of inertia for a cylinder. Now, how can we demonstrate the moment of inertia of a cylinder? That is what we are going to see for our discussion here. The moment of inertia of a solid cylinder is circular iron rod and also hollow cylinder or hose pipe rotating about an axis through its center can be derived as following. So the key terms to understand for our cylinder here is that the cylinder is categorized into 2 parts. One of them we have this solid cylinder. Example of the solid cylinder is the circular iron rod. And also we have the hollow cylinder. And the example of the hollow cylinder, we have this hose pipe. That is what we are going to see how it can be applicable on the moment of inertia. So as we said that this is divided into 2 types. Now we are going to see that how this solid sphere, how this solid cylinder and also hollow cylinder try to rotate on an axis through the center. How can it be rotated on an axis through the center? and it can be derived as by using the following steps. That is what we are going to see on our discussion here. There are two methods that we are going to consider how in order to derive the moment of inertia for this cylinder. So, my dear student, this can be demonstrated by considering. We have to consider. Let us start with the solid cylinder to look at the moment, the formula of the moment of inertia for the solid cylinder. And after this one, we are going to see how can we demonstrate the moment of inertia for the solid cylinder. Now, imagine we have the solid sphere, and this is solid sphere, my dear student, trying to rotate the solid cylinder. The solid cylinder. So we have the solid cylinder, and this is solid cylinder trying to rotate about an axis through at the center. When it rotating, it forms the moment of inertia that we are going to demonstrate we are going to demonstrate on our next slide here. So consider the cylinder of mass m and the radius r rotating about an axis pq passing through the center. Kwamba, let us go and see let us go and see the moment of inertia. Let us go and see, my dear student, let us go and see the solid cylinder, and that is solid cylinder trying to rotate on an axis. It contains the mass m and also the radius r. That is what we are going to see on our figure as it indicated here. Now, let the cylinder be divided into disks of the masses. So, for the solid cylinder, we should look for the small disk. Now, we are going to look some disks that are found inside the cylinder. That we imagine that the cylinder is categorized or is divided into the several disks that we are going to see on our demonstration here. So, the disk that are found inside the solid sphere must contain the mass, three masses. It means we have mass 1, we have mass 2, and also mass 3. But all that cylinder must contain more than 3 disks. Kwa inapokuwa na diski ambazo zaidi ya moja, basi tuta expect in terms of the ascending order or in terms of the end stems. We should write that we have the disk 1 that contain mass 1, disk 2 that contain mass 2, and also disk 3 that contain mass 3, and dash into the end stems of the disk that are found inside the cylinder. So each with radius this one. So each cylinder each disk must contain its radius. Kwa diski zote ambazo zinakuwa zinapatikana kwenye ile cylinder yako zitakuwa na radius ambayo ni sawa. Ni sawa na r as we have been told into our statement here. So consider our figure number 10 for our first topic. And our figure as we see is that we have our figure, my lovely student here, and our figure here indicate the solid circular cylinder. It indicates the solid circular cylinder with rotation axis or at it is a center as we demonstrate here. So, my dear student, how can we demonstrate our formula here? So, as we look at our figure, that this is the axis of rotation, PQ, indicate the axis of rotation. The disk that are found inside the cylinder tried to rotate perpendicular on the axis of rotation through the center. As we observe, we have the disk 1 that contains the mass 1, and also the disk 2 containing the mass 2. Finally, we have the disk 3 that contain the mass 3, my dear students. Now, after this one, we try to see the angular velocity, which is the direction of the angular velocity. This indicating how this cylinder try to rotate on an axis, my dear students. This is what we try to observe here on our figure. So after observing this figure, we are going to see how can we demonstrate the formula related with the moment of inertia for a cylinder. So my dear student, let us proceed from the question number 4.29 here.